Back again with the candy corn data. Here we're going to find the standard deviation of a discrete probability distribution function using our candy corn data that we've been using. So in the previous video, we looked at finding the expected value from the table in Excel using my favorite Excel function of all time, which is equals sum product. I feel like such a fun geek right now. Sum product is my favorite Excel function. Finding the expected value of these tables is like so fun to me. Okay, so in this video, we're finding the standard deviation of this situation. So we don't have one function that will do this for us in the same way that we have the expected value that we can do it with using that sum product. But here what we can do is use sum product in a different way at the very end. So we will still have to kind of create some, we will have to create at least one more column to complete these steps. So if you remember before, this is the formula for standard deviation. So we are looking at sigma, which is the population standard deviation. We find by taking the square root of, now if you remember, standard deviation is the square root of variance. So if we were to remove this square root, we would be calculating the variance, and then we could find the standard deviation by taking the square root of that if we wanted to. So just throwing that out there because that will become relevant later when we're calculating things. So here we have the sum of, so again, sigma means we're adding things together. The sum of x, so each of our random variable numbers, minus the mean or expected value that we calculated, and then take that difference and square it for each and every x value. So we're doing that many times. Then multiply that by the probability that corresponds to that x. So if you notice in this table as an example, we had calculated an expected value of 3.75 in this different situation. And then in this column, what we did was we took this x value, subtracted the mean or expected value, squared that. And then in this column, we took that number and multiplied it by the probability of that value. So everything that we're doing in each of these columns is like located within this row, which is very nice in Excel. As we're learning, and hopefully you're picking up on some patterns, when we have tables, if we can write a formula in such a way that we can reference cells in a particular row, then we can copy and paste that formula all the way down, and it can calculate this thing on repeat as many times as we need it to. So that's what we're going to go do here. All right. So here we have our table again, and in our previous video, we used sum product to find the product or the sum of each of the products of x and their corresponding p of x. We will be using the sum product in this formula, but we can't necessarily use it. I mean, we can, but we're taking it step by step here. Okay, so in this column, what we're going to be doing is we're going to be taking each x value, subtracting the mean that we found, so the 5.91. Then we're going to square that. And right now I'm just typing like the title here just so that I can reference what we're doing. Okay, this is what we're finding in this column. I'm going to go ahead and format it so it will look nice when we... Oh, I meant to do all borders. Please hold. And again, the borders are up here. And if you click on the arrow next to it, you can select like which type of border. I prefer, usually with tables, I go with all borders. Okay, so Excel loves equal signs and functions and calculating things. So here, I'm going to zoom in a little bit actually. So okay, and I'll make this larger. Okay, so if we do equals, then use a parentheses. Now remember, this x, we're grabbing the cell that's 2 to the left. So instead of typing 0, which is actually the number I'm considering here, click on this cell. So when you click on this cell, then you can type minus 5.91, close parentheses, caret, which from the last few videos I've pointed out is shift 6, caret 2. So we're saying square the difference between this possible x value and the expected value of our data set. If you remember too, that standard deviation variance is a measure of spread. We're looking at how far apart data values are from the mean or the expected value. So that's why we're finding differences. We're looking at how far apart or the distance between values, basically. Okay, So here we have now found 0 minus 5.91 squared. But what we want to do is, since we have used this in a way that we've clicked this cell, if I hover over the bottom right and let my mouse turn to the little skinny plus sign, I can click and drag. And what Excel processes this as is, instead of looking at the distance 0 or considering 0, for example, I'll click on this one, it has understood that you are looking for 2 cells to the left, take that value, subtract the mean, and square it. So all of these are that value. And as you saw, Excel did that very quickly. Okay, so if you remember now, our formula for this, we're looking for, eventually we'll take the square root, but we need the sum of the products, where we're looking at this column, so the x minus the mean or expected value squared, and we're multiplying that by the probability here. So we're going to do it this way. I'm going to type variance first. And I'll show you at the end of the video, we can do this all in one cell, but it's just slightly more complicated. So I'm taking it step by step so that we can still process the actual formula for standard deviation, and we're not just like jumping through that in our brains, because it is very important that we understand what we're calculating here. Okay, so the variance, which is the square of the standard deviation, here now we can use sum product. So we're looking at multiplying each of these values. So the difference between x and the mean squared. Okay, I'm going to come back over here so you can see. Sum product of that column, comma. And we're trying to multiply each of these with the corresponding probability. So in our previous videos where you've seen me do use sum product, I've explained what this is doing is, if you highlight columns that are the same size or arrays that are the same size, it understands you are multiplying these pairwise in rows. So it knows you're trying to take the product and then add them all together. Okay, so if we do that, this is the variance of our data set. And then remember the standard deviation, which is also sigma, is the square root. And the square root function in Excel, you can start typing s cube and square root will come up. So square root of this. And we have done this before previously in Excel, so I'm not giving as much detail about that. But you can click on this value and it will take the square root of that exact value instead of taking a rounded one. Okay, so this is the standard deviation of this data set. So I want to point out what this means within context. This means on average or within reason, if we're asking 20 people to make a guess as to how many candy corns are in here, and again, we're recording how many people are guessing within 100 of the real number, and that's 343. Okay, so within 100 of that value. What the standard deviation means is, within reason, we can kind of use this as an upper bound and a lower bound to find common guesses. So for example, if we ask 20 people to guess and the standard deviation here is 2, that would mean on average, if we did this experiment a lot, we'd find that the mean or expected value would approach about 6 with a standard deviation of 2, meaning like 6 plus or minus 2 would be very common expected values for the number of people. So let's think about that. I said if we had 6 minus 2 all the way up to 6 plus 2, within reason, when we ask 20 people to guess, and I'm kind of rounding here just for, I guess, a conceptual understanding of this, a lot of people, or I should say, when we ask 20 people, what's happening is between 4 and 8 people, in a lot of these experiments, between 4 and 8 people would guess within 100. So we can't just say, yes, around 6 people will guess. So what the standard deviation is doing is allowing us to create this, I'll say like a margin of error, or it almost functions a little bit as a margin of error, foreshadowing in our class a little bit, that we can create this interval that we think between 4 and 8 people very commonly would guess, but within 100 of this value. Okay, That's just a small interpretation. Again, that's not necessarily super formal or super rigorous, but I think it's very important to keep reminding us, what is the standard deviation? What does this mean? Okay, one last point here in this video. Similarly, like with the expected value, I wanted to show you how to find this using a table for a probability distribution function. But if we have a binomial experiment where we know this is a binomial experiment, we can actually find the standard deviation very quickly without using the table. So in a binomial experiment, the standard deviation is the square root of n times p times q. So it's the square root of the number of trials times the probability of success times the probability of failure. So as a reminder too, that would mean that the variance we can think of as n times p times q, because the variance is what we find before we take the square root. The standard deviation is the square root of variance. Okay, so if we do this here, we will type equals square root. Okay, n is 20. We had 20 trials. Times p, our probability of success, is that 0.2955. And then our probability of failure, we're using the 0.7045. Okay, and when we hit enter, we should get the same number. Ta-da! Math makes sense. It's awesome. So I want to, again, one more time, just clarify. The strategies I was showing you here to find the standard deviation using the table is for any probability, discrete probability PDF. To use the square root of n times p times q to find the standard deviation, it has to be a binomial experiment in particular. So there's that. Okay. And then just because I have another minute, you can log off if you don't want to see how to do this in one cell. But in fact, I don't know that I've ever actually tried to do this, but mentally I thought I could just now. So let me go for it. Okay. I think if we did, so let's see, we have to take the square root. Y'all are watching me in real time now. We have to take the square root of the sum product. Okay. And what we're trying to do, I'm going to assume like we didn't make this column. Okay, so we're looking for the square root of the sum product of, is this going to work? I don't think it's going to work. Let's try it. Minus 5.91 squared. Okay, so that would be like the first array. We're trying to take all of those and multiply it by the probability. So I'm going to talk through this because I might be okay on this. All right, so we're looking at each of the x values minus the expected value squared. That's one of our columns. Multiply each of that, what you get from that, with the probabilities that correspond there. Multiply all those, add them together. That's what sum product does. And then take the square root. This might work, y'all. Let's see. Excel is so cool. I'm going to leave that up there. That's really cool. Okay, so you can do it in one cell if you really want to. But again, that is quite complicated. So take your time, break it apart if you need to. Okay, that's going to be it. This is a longer video, but I just wanted to experiment, I think, in real time with y'all because I don't know everything in Excel. So I explore a lot as well. Anyway, all right, I'll see you in the next video with our candy corns later. Goodbye.